progress card. So very good morning, students. Welcome to IIT NEET or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the participants of class 6th for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 6th, our ongoing chapter number 2, the second chapter, kinematics. Today we are in the session number 2. So far we completed one session about kinematics, where we discussed about what kinematics deals about, that is about the motion, and different types of motions we have seen in our day-to-day life. How many types of motions will come across? So what is motion, what is rest, and what are the different types of motions that we learned in the last class, right? So as you know that when a body changes its position along with the time or with surrounding, then body is said to be in motion. If the body is not changing its position, then body is said to be at rest, right? So there are various types of motions we have seen, like translatory motion, rotatory motion, circular motion, random motion, oscillatory motion. Like different types of motions we have seen, video also we are given explanation, right? Then today what we'll discuss is when body is in motion. Suppose a body is starting from some point and moving. Every moving body will come across some physical quantities. Every moving body will come across some physical quantities like distance, because moving body will cover some distance or displacement. It has some speed or velocity. It accelerates or decelerates. It takes some time. All these are the physical quantities which come across when the body is in motion. Or simply we can say terminology. Terminology related to body in motion. When a body is in motion, some terms will come across. Those terms we'll discuss today. Few of them, right? So, see here. So we already discussed about all the types of motion. These are the types of motions what we discussed in the last class along with the video. Translatory motion means a body moving, all the particles of the body moves in same direction, straight line. Then they are called translatory. If they are moving in straight line, rectilinear motion, it take the turning, curvilinear motion. Then rotatory motion, you can see about a fixed point like top. Oscillatory motion, to and fro from same point. Periodic motion like earth revolving around the sun. Random motion means irregular, zigzag. Circular motion, right? These are the points what we discussed in the last class about the types of motions. Okay. Now when you enter into the next part, that is the terminology. Whenever body is in motion, it covers some distance or displacement. So I should know what is the distance, what is the displacement, right? For example, simple way I tell. Later I'll discuss about the differences. Okay. See here. Here body is at A. It should reach the destination B, right? So body goes like this and reaches the B. Right? This entire path is called distance. The entire path of the body followed by a body. Whereas, what is the shortest path? You can go directly like this only, A to B. So this is called displacement. The entire path followed by a body is called, or length of the actual path followed by a body is called distance. Whereas, the shortest distance from initial position to final position is called displacement. Right? These are the two terms. So distance traveled never be negative or zero. Distance cannot be negative or cannot, because it's not having any direction. Distance does not have any direction. That's why it's a scalar quantity. Right? Scalar quantity. No direction for that. As there is no direction, there won't be any negative also. Distance cannot be negative or even zero. Whereas displacement can be either negative or even zero also, because when a body travels in opposite direction, we get negative value. When a body comes back to original position, it becomes zero. For example, see, a body covers circular path. It started from A, right? It again came back to A. So what is the distance? Distance is nothing but circumference of circle. We can take 2 pi r. Correct. So when body comes from A to again come back, the distance is 2 pi r. Displacement is zero because it came back to same position. Similarly, in straight line also. A to B. Suppose a body moves from A to B and again it came back to B to A. So displacement is zero. Distance is, you have to take, for example, is 1 kilometer. Back also 1 kilometer. So distance traveled is 2 kilometers, but whereas displacement is zero because it came back to original position. Right? There is a very two important terms related to motion of a body. Distance and displacement. See, there are so many examples are given. Displacement is the shortest distance between initial point and final point. The total, you can go from one place to another place in so many ways. Suppose when you are going from home to school, you can go directly to school or you can go some other place to school also. So direct short route up to school is called displacement. Right? And the total entire length of the path is called distance. See, so many things are given here. Just once we'll go through before going for some video. Right? See, the magnitude of displacement of the body is always less than or equal to distance. That is, so displacement of distance is always greater than or equal to displacement, or displacement is less than or equal to distance. Distance is always greater. Only one case, both distance and displacement are same. That is in straight line. When body reach from A to B in straight line, distance also same only, displacement also same only. But in all other cases, except straight line, in all other cases, distance is much more greater than displacement. That's what is given. Displacement is always less than or equal to distance. Distance is a scalar quantity, displacement is a vector quantity, because distance does not have any direction, whereas displacement will have specific direction. So the displacement of the body have zero, positive, negative values. Displacement. But distance has always positive. Distance has always positive only. Distance cannot be negative. Displacement can be either negative or positive or zero also. Right? So this is the, so if the object traveling along the following paths, these are mathematical shapes. In such case, what to do for the, what is distance, what is displacement is given here. Right? Can see here. Right? First one, a body travels from A to A. A to A. So it moves from A, like this moves, and again came back to A. So how many A, what is the length here? A, this is also A only, because square. A only, A only. So when a body comes from A to A, the distance is 4A. A plus A plus A plus A. What about displacement? Zero, because it came back to A only. The initial position and final position are same. Then zero. A body travel from A to A, again same, I told example. It comes from here and again move to A only. Then circle, this is circle path. So distance is nothing but, the total distance is nothing but circumference of circle given by 2 pi r. As the body came back to again to A, the displacement is zero. Got it? Then body travels from A to B. So this is semicircle. Half of the circumference, 2 pi r by 2, that is pi r. Pi r is the distance. Displacement is shortest one, see here, A to B. So this is R, this is R. So what is that? 2r. Try to understand. The shortest path from A to B is nothing but diameter of the circle. Whereas the actual length of the path is given by A to B like this. That is half of the circle. That is semicircle. Circumference of semicircle is given by pi r, because 2 pi r by 2 you can take. You get pi r. Right. So in every case, whatever the shape, whatever is the path, we can find out distance as well as displacement also. Right. Now, next one. A body travels from A to B is nothing but 1/4 of the circle. So this is see, full circle, half circle, 1/4. 1/4 means 2 pi r by 4 you get. So 2 1s are 2 2. So pi r by 2 is the distance. The distance traveled is this is given by pi r by 2. And what is the displacement here? A to B. You can take the root 2 by, that is from the formula of Pythagoras theorem. AC square is equal to AB square plus BC square. You get the root 2r for the 1/4 circle. Right. So like that, any shape given, we can find out the, you can see here. So body travels from A to B. Okay, same. A to B, this is actually. There are two ways are there. This is the shortest path is nothing but displacement, A. And this path is, again, A to B, maybe given wrong it is. It is 2A. Correct in your textbook also. Because A plus A. 2A. Or directly because A only. Same, A to B also travels like this. Right? So this is given by the shortest path. This is A and A. A to B can take C. A plus A, 2A. But how this come? This is shortest path is this. That is AB square is equal to, suppose say AC square plus BC. Formula you can apply and get root 2A. That is Pythagoras theorem. Okay. Clear? So like that, for any shape, we can find out what is the actual path and what is the shortest path. Right? That is about the distance and displacement. So before going for the next topic, we'll go for one video on this and we'll see the major differences between them.
When we move from one place to another, the measure of total length we cover is called the distance. So you have to travel to this town and the best route is straight up north. But because of roadworks along the way, we have to take a detour and the distance covered would be something like this. Now when the roadworks are completed, the distance needed to be covered will be something like this. Distance is measured in meters and denoted as lowercase m. The distance between these two towns is about 20,000 meters, but because of the detour, you had to cover a distance of 50,000 meters. Okay, so nobody likes big numbers unless it's your salary. So we should also know that a kilometer is 1,000 meters. In our example, we can say that instead of 20 kilometers, you traveled 50 kilometers. Is distance a scalar or a vector quantity? Think about it. If you say someone traveled 20 kilometers from this point, we can't really tell where they landed up. Maybe here, maybe there, or maybe they just went around in circles. As it does not specify a direction, it is a scalar quantity. That brings us to displacement. So what is displacement? Distance with direction is displacement. Distance with direction? What do we mean by that? You made 2 separate trips to this town. Was the distance covered in both the cases the same? Have a good look. It wasn't. In each of the 2 cases, the distance was different. The time you took for the detour was greater than the time you could go straight across. But if you call someone to tell them where you are, in both the cases, your location is this town, which is 20 kilometers north of your home. The displacement in both the cases is the same. You traveled 20 kilometers north. North shows the direction, and because direction is specified, displacement becomes a vector quantity. Now let's look at this example where a mother asks her son to quietly stay where he is while she takes a quick nap. So now the child runs back and forth many times and returns to the original spot before the mum wakes up. The mum wakes up and sees the child in the same spot, and as she hasn't observed what happened in the last few minutes, she assumes the child has not moved. The child, being the future expert in physics, has in fact disobeyed her instruction and covered lots of distance. But at the same time, he can argue that he did follow his mum's instruction. Lots of distance covered, but zero displacement. If the distance travelled is a straight line, the displacement will be the same magnitude as the distance, but with the direction provided as well. In most cases in our day-to-day lives, the distance covered is greater than the displacement seen. Running errands and travelling back and forth between places cause the amount of distance to build up, though you may not end up very far from home. If you've really understood the difference between distance and displacement, you should be able to answer the next question. When a passenger travels by taxi, is he charged based on the distance or displacement?
So definitely a distance, displacement.
Taxis charge passengers based on distance. If you go to the neighboring town
Right.
and return in the same taxi, the taxi meter shows you the charge for the entire round trip. If you now try to explain to the taxi driver that you have had no resultant change in your location and hence you must pay nothing, it will not impress him much.
Right. So very interesting example at the end. Right. What he's saying, suppose you have taken one taxi. You started from home, you went to some market, and you came back in same taxi to home. If you say that taxi driver, my displacement is zero, I won't pay money. Will he listen? No. So physics won't work there. But actually your displacement is zero, but we have to pay as per the distance covered. They will charge as per distance covered. Right. So I'll show you one more wonderful difference also between these two. You can see what is the. So these are the differences between the distance and displacement. So many are there. So many differences you can find. See, first, when you see distance, definition, if you see, the complete length of the path between any 2 points is called distance. The displacement is a direct length between any 2 points when measured along the minimum path. That is called shortest path. So it is denoted by D, it is denoted by S. The calculation of the distance, the direction is not considered. To calculate the displacement, direction is considered. Distance is a scalar quantity and is having only magnitude, no direction. Displacement is a vector quantity because it have both magnitude and direction. Distance gives the detailed route information that followed by traveling from one point to another, as displacement refers to the shortest path. So distance is equal to speed into time. So displacement is equal to velocity into time. So the distance can only have positive values. Distance displacement can have positive, negative, and even zero also. Distance is not indicated with arrow because there is no direction. Displacement is always indicated by arrow. The distance can be measured along the non-straight path. Displacement can be measured along the straight path. Distance depends upon the path, that is, changes according to the path taken. Displacement does not depend upon the path and is only depends upon the initial and final position. So these many 10 differences you can find out from a small two terms. Small two terms can be defined and can be differentiated in the 10 ways. See, imagine, generally in common words, both distance and displacements sound same. We'll think that it is same, but physics point of view, there are the huge number of differences. Right? So very, very interesting points. This is very important topics, right? Then, so as we move back, so next, time, because time also, every moving body or body at rest, it will take some time. Body may be moving or body may be at rest, no matter. Time always will move, right? Time never stop for anyone. time. So what is time? Time is nothing but interval between two events. Right? Interval between two events is called time. For example, my class starts at 10 o'clock. It ends at 10:40. So this 40 minutes is called the time duration of the online class. This is a common. Anything. For example, your school starts at 9 o'clock, ends at 4 o'clock. So 9 to 4 is the duration of school. The duration is called time. Two events. The interval between two events is called time. To measure time, there is a simple pendulum is there. Of course, there are so many types of watches are there to measure the time. So time generally measured in seconds commonly. 1 minute is equal 60 seconds, 1 hour is equal 60 minutes. You all know. Okay. 1 month is equal 30 days or 31 days, whatever it may be. Okay. So this is completely about the time, and special units of time are so many are there. Not only seconds, hours, months, weeks, years, decades, centuries. They're also having some solar day, mean solar day is there, leap year is there, lunar month is there. All this comes under the units of the time only. See, special units of the time. You can check all these things. Right? So distance, displacement, and time related to that answers are here. You can find out easily. If you understand the concept, you can answer all these questions. Try and write in your notebook. Right? If any doubts are there, you can consult your teacher because we provided the answer key also, solutions also. Now the next one is speed, velocity, acceleration. Another three words. Speed is nothing but rate of distance. How fast you are moving. That is distance by time. Distance traveled by time is called speed. That is, if the body travels a distance of s in time t, then speed v is equal to s by t. Distance by time. Whereas velocity is displacement by time. As it is distance, there is no direction. We are not considering direction to measure the speed. Only will measure with some meter. Speedometer is there, or you can use the formula. In your vehicle, if you see any two-wheeler or four-wheeler, you can have the meter, which measures the how much speed you are going, how many meter per second, how many kilometer per hour you are going. That we can measure, find out. Okay. So, as it is a distance by time, it is measured in meter per second. So, speed is measured by meter per second or centimeter per second or kilometer per hour also, biggest units. Kilometer per hour, where 1 kilometer per hour is equal to 5 by 18 meter per second, or 1 meter per second is equal to 18 by 5 kilometer per hour. Very important conversions will come across. Okay. So the smallest unit is meter per second. The larger unit of kilometer per hour, which you can see in the vehicles. When you suppose see one two-wheeler, you can find the speedometer. That speedometer will show how much speed you are going. How much 40, 50, 60, 70. There are some limits also they will keep on some roads. Okay. That is about the speed. Speed is nothing but the rate of distance. It doesn't mean it means that how fast we are traveling. How fast you are traveling is measured by speed. Does not have any direction. Okay. It is measured in meter per second or centimeter per second or kilometer per hour. So this speed also, there are different types of speeds are there. Uniform speed, non-uniform speed, or average speed, types of speeds, or instantaneous speeds. So average speed you can see. So you are traveling from Hyderabad to Vijayawada by two-wheeler or four-wheeler, whatever you want. For some distance, road is very good to travel with some speed. Next, second distance you travel with less speed. Third distance you can travel with much more speed. Then what is the average speed if you ask? Simple, begin by total distance by total time. We'll get average. How much total distance you traveled and how much time you taken. For example, 200 kilometers. You covered in 4 hours. 200 by 4. Right. This is 50 kilometer per hour. Average speed. Like that you can calculate. So there are so many complication questions will come based on this. Because average speed is a very important You understand the speed. So we'll see when you go forward, we'll have some problems also. Then uniform speed. Uniform is constant. Suppose see a diagram. See diagram here, you can understand easily, simple way. You started from 0 meter. You move to 4 meters. 4 meters you take 1 second. Next 4 to 10, 6 meters take 2 seconds. Next again 13, 3 meters will take 3 seconds. So there is a non-uniformity. There is no constant. So for example, you take A to B. This is 1 kilometer. This is 1 kilometer. First 1 kilometer moved in 5 seconds. Second also 5 seconds or 5 minutes, whatever it may be. So when you move like this, then we can call it as uniform at velocity, uniform speed. If not like this, there is a non-uniformity is there. There is no change. Every time they are changing. Distance is changing, time is changing. That is called non-uniform or variable speed. Variable means changes. Unequal time, equal distance. Or unequal distance, equal time. Whereas uniform is nothing but a body has uniform speed, it travels equal distance in equal interval of time. Same distance, same time if you travel. Then you can call it as you are moving with the uniform speed or constant speed. If not, we can call it as a variable speed or non-uniform speed. Suppose instantaneous, fourth one. What is instantaneous? Anytime. So meter is there, right? You can clearly understand here. We have 1 meter where you can find in your vehicle. Speedometer, this is. You are traveling by 2-wheeler or 4-wheeler speed. Somebody called you and asked what speed you are going that presently. You can see and tell. Either you are going by 120, 140 or 100, 40, 80, whatever. That is called instantaneous. The speed of a body at any instant of time. You can calculate by using that meter. Right? So this is called, so there are 4 types of speeds. Speed is nothing but distance by time, rate of distance traveled, which is measured in either meter per second or centimeter per second or kilometer per hour. The speed can be either average speed or uniform speed, non-uniform speed or instantaneous speed. Clear? Now velocity, same. Instead of distance, you can take displacement. That's all. So displacement is there means a vector quantity, whereas speed is the scalar quantity because it is a distance by time. This is rate of displacement is called velocity. It is also measured in same meter per second or centimeter per second. You in that also same will have covering equal displacements, uniform velocity or constant velocity, non-uniform velocity or variable velocity, average velocity, right? It's common for both of these velocities, right? This is about the speed and velocity. Speed and velocity. So in the next class, we'll discuss about what is acceleration, what is a negative acceleration, and meantime we can almost come to end. Acceleration types is there. We'll finish this particular chapter. You have to solve all these things. We'll move to the next chapter, third one. Okay. Right? So if you see here, acceleration is a very simple part. You all know accelerator. You know accelerator, na? Acceleration is that increasing of speed. In 2-wheeler or 4-wheeler, we have accelerator. When you press the accelerator, speed will increase. That is increasing of speed. Rate of change of velocity is called acceleration. Rate of change of velocity is called acceleration. If it is time to time, it is increases, it is called positive acceleration. If it is decreases, it is called negative acceleration or retardation. Okay, so we'll finish up this in the next class in details and we'll complete the chapter, right? Then we go for the third chapter. So that's all for today. After we discussed about what is distance, what is displacement clearly, then what is velocity, what is the speed, types of speeds, types of velocities, and just introduce about acceleration. So in next class, we'll complete this chapter by completing the acceleration and all. If time permits, we'll go for some exercises also before going for the third chapter, laws of motion. Okay. So that's all for today, students. Thank you all of you. Have a wonderful day. Thank you.